Alright, today we're going to do scientific notation, and the numbers are going to start off either looking like this, but A is not between 1 and 10, or it'll just start off as a regular decimal number. Alright, so scientific notation, in order to be scientific notation, has to look like this, and this number here called the abscissa needs to start at 1, it can equal 1, and go all the way up to 10, but not equal to 10. So if it equals 10, you have to change it back to 1.0, and then you modify the power of 10. Now, other teachers teach scientific notation this way. If you move the decimal point to the left, you do something. You move to the right, you do something else, right? I like to do it on a complementary basis. And what I mean is that whatever happens to the abscissa, bigger or smaller, the opposite happens to the power of 10. And that way you don't have to remember, well, let's see, right I'm supposed to do this, and left and then you've got all this other stuff. It's real simple. This gets bigger, this gets smaller. This gets smaller, this gets bigger. They complement each other. Whatever you do to one, you do the opposite thing to the other. And you move the decimal point to the right of the first non-zero digit. It looks like this. If I have 79,349.872, the first non-zero digit is 7. So you move the decimal point there. That's what step 1 is. If you have a decimal like 0.00000000000000932, that's the first non-zero digit. You move the decimal point there. Right? That's what step 1 is. Simply move the decimal point to the right of the first non-zero digit in the number. Step 2. If that move made A smaller, increase N by however far you moved it. So here, notice, if I made smaller. So from here, this number is 79,349, right? By moving it from here to here, now it's 7.9, right? Which is smaller. Okay? If you make A smaller, you're going to make N bigger by however far you moved it. How far did I move this?
4.
4, so I would take N and add 4 to it. If your move makes A bigger, so this is A, which is this decimal number, right? If I move it right, it becomes bigger, right? So 0.00, whatever, all this is really, really tiny. You move the decimal point there, now it's 9.32, it's bigger, right? By 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 decimal places. You made this 13 bigger, so you make N 13 smaller. That's all you have to do. If you make A bigger, you make N smaller. If you make A smaller, you make N bigger. And however far you move the decimal is what you're going to add or subtract to N each time. If you start off with an N, that's what N is. If you don't, N equals 0. So if it just starts off as a regular decimal number like this is times 10 to the 0 to begin with. You got to make it 10 bigger, or 4 bigger, so it'd be 7.9349872 times 10 to the 4th. All right, so let's try example 1. Where does the decimal point belong? Between what and what?
4 and 8.
Between 4 and 8. So, job 1, step 1 is to write the abscissa, this number, as a number between 1 and 10, and all you have to do to make that happen is simply slide the decimal point over just to the right of the first non-zero digit. Just like that, you're right between 1 and 10. The number of spaces it had to move was 1, 2, 3, 4 spaces, and we made this become bigger, right?
Mm-hmm.
So I need to subtract 4 for N. So again, whatever you do to the A value, making it bigger, you have to do the opposite to the N value, making it smaller. And there is no N to begin with, so we're going to start off with N equals 0. 0 minus 4 is negative 4. 4.87 times 10 to the negative 4th power is the scientific notation version of 487 millions. Is believable. That's right, isn't it? Tenths, hundreds, thousands, 10, yeah, 487 millions.